Good morning and happy Moodle Day. We'll be going over this bell ringer tomorrow, so please write these down and attempt to do them, and then we'll grade them tomorrow to make sure that we're okay. Here's the formulas. I want you to find A, B, C, and D, and then create a T-chart for 5 points. Okay, here's some announcements. The homework that you had for this weekend, we're going to be doing this later in the week, so I will be stamping this tomorrow. So that we can get to it and do some review with it later in the week, and then we'll collect them after the exercise. You have to have my initials for full credit, and please do not lose them. Okay, so I want to go ahead and up front get your homework out here. This is the homework that you'll have. It's out of your book. I will be taking a picture and posting it onto Moodle for you. Okay. We're going to learn about solving trigonometric equations. This is the last part of section 5.1 in your book. Okay, so you're going to be using standard algebraic techniques that you've used before in order for solving equations. Big thing to think about here is we're going to be looking for factoring and like terms. We're going to isolate the trig function and then use the inverse trig functions to determine solutions. So I'm going to walk through a bunch of examples and hopefully they will help you. Okay, so the first one is pretty straightforward, right? 2 cosine x minus 1 equals 0. So the first thing we're going to do is isolate our trig value. Add 1 to both sides. Now we divide by 2. And we have cosine x is equal to 1/2. So we know what value of, right, this is the same thing as cosine inverse of 1/2 equals x. So we get in quadrant 1, which I think I have this that pops up. Okay, so cosine is positive in quadrants 1 and 4. So we have this positive 1/2. So we look in there, and the reference angle is pi over 3. So we go ahead and have pi over 3 and 5 pi over 4. Okay, next one. Okay, so now we're looking at tangent squared x of x minus 1. Again, we're going to go ahead and isolate our trig function. We need to take the square root of both sides. So in this case, we get the tangent of x is equal to plus or minus the square root of 1. So we have tangent of x is equal to positive 1, and the tangent of x is equal to negative 1. Okay, so this includes all 4 quadrants, okay, and we have pi over 4, because remember we're looking at the tangent inverse when it is equal of 1 will give us our x. Okay, so that gives us all of these values. Okay. Looking at that previous page, if for some reason my thing went ahead, okay, so x was equal to, for the cotangent of x is equal to pi over 2, that's a pi, and 3 pi over 2. But for the square root of 2, that's outside of my range, and so that's the empty set. So this is the only answers. Okay, so let's go ahead and look at this one. Oh, this is it. Okay. Let's look at this one. 2 sine squared x minus sine x minus 1. Okay, this is kind of in the format x squared minus x minus 1, correct? So we can see that this is a difference of squares, and we can go ahead and write this by factoring. Okay, so we have 2 sine of x plus 1, and I have sine, this is a 2 sine of x minus 1. So now I have 2 equations that I can set equal to 0. 2 sine x plus 1 equals 0, or sine of x minus 1 equals 0. So let's go through each of these. I'm going to subtract 1, 2 sine of x is equal to negative 1, divide by 2, sine of x is equal to negative 1/2. We know that these are, look at the quadrants, where is sine 1/2 negative, and we're going to get x is equal to 7 pi over 6 and 11 pi over 6. Here, this one's a little bit easier. Again, this is where sine of x is equal to 1, and it's x equals pi over 2, and these are all your answers. Okay, so let's try and look at a couple more examples. I'm just going to go through and write the steps, and you can play and pause as you needed. Okay, so I'm going to do a little algebra cheat here, and I'm going to replace sine squared x with using our trig identity, which is this is equal to 1 minus cosine squared x. That way I have all of the same trig function. Okay, so we can use our identities to help us with these. So we're going to go ahead and distribute this. 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Okay, now I'm going to go ahead and combine like terms. And I get negative 2 cosine squared x plus 3 sine cosine squared x minus 1. Okay, so I'm going to go ahead and divide everything by negative 1, so that way I get 2 cosine squared x minus 3 cosine x plus 1 equals 0. Now I'm going to factor this, right? This is in the form 2x squared minus 3x plus 1. We can factor that out and get 2 cosine x minus 1 times cosine x minus 1 equals 0. Set each of these equal to 0. Okay, so for this one, we have pi over 3, right? And 5 pi over 3. And this one is 0. Okay, this time we're going to do cosine x plus 1 equals the sine of x. Okay, I'm going to go ahead and square both sides so I can get it into one trig function. Okay, so if I take this and square it, and this and square it, when I square this and FOIL it, I get cosine squared x plus 2 cosine x plus 1 is equal to sine squared x. Okay, so now I can move things around, and like I did in the last one, I'm going to use my trig identity here. So I get cosine squared x plus 2 cosine x plus 1 is equal to 1 minus cosine squared x. Okay, so I'm going to move things around, add cosine squared x to both sides, and subtract 1 from both sides. So I end up with 2 cosine squared x plus 2 cosine x equals 0. Okay, so I'm going to go ahead and factor out a like term, 2 cosine x, and it leaves me with cosine x plus 1. Set both of these equal to 0. I'm going to do that over here. So 2 cosine x equal to 0, which cosine x is equal to 0, and x is equal to pi over 2 and 3 pi over 2. And cosine x plus 1 equal to 0, cosine x equal to -1, x is equal to pi. Now, you really should be plugging all of these values back in to the original equation to verify that it's true. And when you do this, you'll find out that this one doesn't work. So my solution is actually x is equal to pi over 2 and pi, and that is it. So you do have to check your solutions. Okay, so let's look at another one. Okay, so this one's a little bit more complicated. I'm not sure if you have any in these in your homework, but I want to look at them anyways. So we have the cosine of 3x equals 1/2. Okay, so this is a complicated situation. This is actually saying cosine of theta equal to 1/2. So we can solve this, and we know that cosine of theta is equal to 1/2 at pi over 3 and 5 pi over 3. But we're not saying theta is equal to that. We're saying 3x is equal to that. So we then can divide each of these by 3, or multiply by 1/3, to get what the angle actually is. Because remember, we talked about this. This is multiplying or changing the angle. So we in turn get pi over 9 and 5 pi over 9. The problem is that we aren't done here. Okay, so remember that we go from 0 to 2 pi, right? It must be less than or equal to 2 pi and greater than or equal to 0. So we have to find out if more solutions exist. Okay, so what we're really going to do is we're going to have back at this 3x step, right? And we had pi over 3, and we had 5 pi over 3, but we need to find the additional coterminal angles. Remember from chapter 4, coterminal angle is where the values are all the same and they circle around and go back. Okay, so that gives us 7 pi over 3 and 11 pi over 3. Okay, so now we divide these by 3, which we already did, these two, and they're on our list here. So this becomes 7 pi over 9, and this becomes 11 pi over 9. Are we greater than 2 pi, right? We're still not greater than 2 pi. In order to get to 2 pi in terms of 9, we need to have 18 pi over 9, right? So that's really what we're looking for. So as long as we're less than that, there's still more answers. Okay, so going back to here, we're going to go ahead and add to this. And we're going to find 2 more coterminal angles, right? If you notice here, right, what we're jumping by, right? So we added 6 there, we added 6 there. Okay, so let's go ahead and add 6, and we get 13 pi over 3, and we add 6, and we get 17 pi over 3. So these become our two new terms, and we get 13 pi over 9, and we get 17 pi over 9. So we're still less than this, so let's go ahead and find two more. So add 6, we get 19 pi over 3, and we get 23 pi over 3. When we convert these, we get 19 pi over 9 and 23 pi over 9. These are both greater, so this is my solution set. That one's a little complicated. I'm not sure if you'll have any of those in your homework, but it's for you to look at. Have a wonderful day.